spiral nebulae and discover that they were far too distant to be part of our own galaxy. And the rest is astronomical history. The supposed nebulae turned out to be independent galaxies and, virtually overnight, provided the realization that the universe is far larger than previously assumed. Hubble also realized that the other galaxies are moving away from us, and that the speed of this galactic flight actually increases with distance. However, it was not the galaxies that were moving through space. Rather, it was space itself that was continuously expanding. This discovery revealed that the universe is constantly expanding, and, true to the motto, what grows must once have been much smaller, it ultimately laid the foundation for the Big Bang Theory. How many galaxies are out there? Hubble's discoveries caused the previous understanding of the universe to collapse like a house of cards. From then on, it was clear that the Milky Way did not represent the entire cosmos, and that we are only a tiny particle in an unimaginably large mosaic of galaxies. But how many galaxies does the observable universe actually contain? Well, in fact, astronomers had only a vague idea of this until the 1990s. Their estimates were largely based on relatively bright, easily visible galaxies, while many smaller and fainter examples escaped our gaze. To finally shed some light on the galactic darkness, the Hubble Space Telescope turned its gaze into space in 1995. More precisely, Hubble spent 10 days observing a tiny, seemingly empty spot in the sky, and ultimately revealed the universe in unprecedented detail. Consisting of 342 individual images, the Hubble Deep Field showed over 3,000 clearly recognizable galaxies at a distance of up to 12 billion light-years. However, the famous image not only showed the remarkable diversity of galactic worlds, but also that the universe is much denser than previously thought, especially in the early cosmos. Even then, it was clear that the actual number of galaxies in the observable universe must be far greater than previously thought. The ultra-deep field of 2004 and the extreme deep field of 2012 further deepened our understanding of space. And that is meant quite literally, because the two images show significantly more galaxies, some of which are over 13 billion light-years away from us. In addition, the deep fields also enabled astronomers to approximate the total number of galaxies in the observable universe. Specifically, they were able to determine the galaxy density per square degree of the observed areas and then extrapolate this to the entire sky. And so it came to be that the number of galaxies was henceforth estimated at around 100 to 200 billion. But as we now know, this figure was dramatically too low. Hidden worlds: why we overlooked 90% of galaxies. In 2016, a team led by Christopher Consolis from the University of Nottingham conducted another galactic census. For their Great Observatory's Origins Deep Survey, the researchers once again used the Hubble Deep Fields and combined them with images from other telescopes. This ultimately resulted in a three-dimensional model of a tiny section of the observable universe, which enabled a completely new galaxy inventory to be created. In detail, the 3D model not only showed the spatial distribution of galaxies, but also indirectly showed the chronological sequence of different generations. In combination with a mathematical model, the experts calculated the average galaxy density in different time periods and were thus able to deduce the number of galaxies in space that are actually invisible to us. And at the end of this cosmic census, the exciting result was that the universe is much denser than previously thought. In total, there must be at least 2 trillion galaxies out there, about 10 times more than previous estimates suggested. In light of this astonishing finding, Consolis was quoted as saying, "It's just incredible that more than 90% of the galaxies in the universe have yet to be explored. Who knows what exciting properties we will find when we explore these galaxies with future generations of telescopes." The crucial question now, of course, is why 90% of all galaxies have escaped our attention to date. And the answer is quite simple. According to this, the majority of the overlooked star clusters are simply too small, old, and faint to be observed by our telescopes. Accordingly, most of these galactic oldies are likely to resemble the dwarf galaxies that surround our Milky Way as satellites. Astronomers generally assume that in the early days of the universe, there were more galaxies than there are today, but that they were smaller. Over time, many smaller structures merged into larger galaxies, resulting in an overall decrease in galaxy density. Well, at least that's the theory. However, Consolis' work is now already a few days old, and the future generation of telescopes he mentioned has long since begun. In fact, the James Webb Telescope is currently looking deeper than ever into the most remote and ancient secrets of the universe, and showing that many established assumptions need to be revised. As mentioned, it was long assumed that the early galaxies of the cosmos were significantly smaller than their modern counterparts, but Webb has proven that this is simply not the case. It has now detected a whole series of galaxies that existed just a few 100 million years after the Big Bang, and yet were already almost as massive as the Milky Way is today. According to conventional wisdom, however, there was not enough normal matter at that time to form such galactic heavyweights. And the question of how these objects managed to grow so quickly, so early on, will probably keep astronomers busy for some time to come. And to make sure we can always keep you up to date, click on the subscribe button now. Join our community and never miss a new video from us again. See you soon.